Hi everyone, this video is going to deal with dimensional analysis or what we like to call the factor label method. Dimensional analysis is a procedure that's used to convert between units in solving problems. So basically, if all the units cancel except the desired unit, then the problem was solved correctly. This is a method that allows you to convert from one unit to the other. And the general formula is given right here. So basically, let's say I give you a unit. Let's say it's meters. And we start with meters, and I want to get to centimeters. The only way that you can get rid of a unit is if you divide by that unit. So I like to call that area, like wherever you put on the bottom of a fraction, I like to call that sort of like the trash can, right? Because you don't want that anymore. You want to get rid of that so you can get to the desired unit. So you would basically start out with the given unit, and then to get rid of that given unit, you would have to divide that by that unit. And there has to be a relationship between the given unit and the desired unit. So that way, when you put that all together, you can cancel out the given unit and you're left with the desired unit. All right, so in the factor label method or the dimensional analysis method, any factor or expression can be multiplied by 1 without changing its value. What all that really means is that a unit factor is anything that you can describe in two different ways. So for example, 12 inches is equal to 1 foot. We all know that. So I could go ahead and write that 12 inches is the same thing as 1 foot, making a relationship between those two different units. But at the same time, what if I flip that and I said now 1 foot is equal to 12 inches? It still means the same thing, right? If you multiply those things together, it's still equal to 1 because everything cancels out. So that right there, the fact that I've basically flipped 12 inches over 1 foot and 1 foot over 12 inches, that's what's called a unit factor. Whenever you do a dimensional analysis problem, you start out with a given unit. And to get rid of that given unit, you have to multiply it by a unit factor. In essence, what that is a fraction that has a relationship to it. For example, 12 inches is equal to 1 foot. Really, when you read it, you should read it as a sentence. You should read it as a relationship. Whenever you write a fraction top and bottom, when you're doing unit conversions, that unit factor needs to be a relationship that makes sense. For example, 12 inches is equal to 1 foot. Let's try to work with this now. So here are a couple of examples that I want to get through in this video. The first one is very easy. It says how many feet are in 765 inches. When you do problems in this class, I want you to make sure that you are very careful in writing everything down. And what I mean by everything is you have to make sure you write out the complete units, and you have to make sure that your answers are always given in the correct number of significant figures. Now is when these things are going to start becoming important. The first question is very easy, like I said. How many feet are in 765 inches? So this is a very simple problem, but you have to know where to start. One of the main questions that I get from students is that they don't know where to start in certain word problems. Usually you start with what they don't want. So for example, here they want how many feet. So you wouldn't start out with feet because that's the unit they want. You would start out with inches. So they want to know how many feet are in 765 inches. So the way that I would write it is 765 inches. And make sure that you learn your abbreviations, proper abbreviations for all of your units. Inches is IN, period, right? So 765 inches. I have to convert this to units of feet. To do this, I need a unit factor. And I know that there's 12 inches in 1 foot. See, that's a relationship that we just saw on the slide before. So I'm going to go ahead and write 12 inches on the bottom. Inches has to be on the bottom because I want to get rid of that unit, inches, to get to something else, which is feet. So I'm going to write inches on the bottom and feet on the top. And then I go ahead and write in the numbers. I always try to set up my problems first as far as the units, and then I go back and put in the numbers that actually fall into place into those different unit factors. The most important part of doing these type of problems is setting up your path. So if your path is correct, then you're more than likely going to get the right answer. Now that I have my unit factor, inches to feet, well, inches cancels out, and I'm left with the unit that I want. And now all I gotta do is take 765 and divide it by 12. That gives you, if you put that into your calculator, that gives you 63.75 feet. Remember, whenever you do a problem, you gotta make sure that you give me the correct number of sig figs and correct units. So, do you remember what we said about exact conversions in the last video? 1 foot is equal to 12 inches is an exact conversion. So I wouldn't use that unit factor when I'm trying to calculate how many sig figs I need to report in my answer. What's the only thing here that has been measured? The only value that's measured is 765, and that has 3 sig figs. The calculator, it gives you 63.75, but I know that my answer can only be 3 significant figures. So I would report it as 63.8 feet. All right, let's move on to another one. How many seconds are in 2 years? So they want to know seconds. So I'm not going to start with seconds. I'm going to start with years. And they tell me 2 years. The only thing that's measured here really is the 2 that they give you, the 2 years. So that means that your final answer should have only 1 significant figure. These are things that you need to start learning right off the bat so that they become second nature to you. All right, so let's set this up. We would start out with 2 years. And now I need to get from years to seconds. That's a pretty long conversion, but all of the unit factors are pretty easy. I can go from years to days. Well, I know how many hours are in a day, and then I know how many minutes are in an hour, and then I know how many seconds are in a minute. So I have my path. Now I would go back and plug in all the numbers. So I know that there's 365 days in 1 year. That crosses out my years, and I have days. Now I know that there's 24 hours in 1 day. That crosses out my days. I'm left with hours. Now I know that there's 60 minutes in 1 hour. That crosses out my hours. And of course, I know that there's 60 seconds in 1 minute. That crosses out my minutes, and guess what I'm left with? Seconds, which is exactly the unit that they want. If I plug all of that in, so all I'm basically doing is going 2 times 365 times 24 times 60 times 60. If you plug all that into your calculator, you get 6.3072 times 10 to the 7th seconds. But I know that my answer can only have 1 significant figure. My answer would end up being 6 times 10 to the 7th seconds. Does it matter if I give it to you in scientific notation or in what we call a floating decimal? No, it doesn't matter because I didn't specify, right? If the question specified, please give your answer in scientific notation, then you give it in scientific notation. It's just that 6 times 10 to the 7th is a pretty long number, so I rather just write it in scientific notation. All right, let's go on to the next one. Calculate the speed in inches per second if it takes a jogger 8.92 minutes to complete 1 mile. This one's a little bit more complicated because you have to actually know what you're reading. When you read a problem, make sure that you understand how to translate that problem of words into a math equation. First of all, they want to know inches per second. They want you to calculate the speed in inches per second. So that's not what you would start with. You would start with what they give you. They give you that the jogger takes 8.92 minutes to complete 1 mile. I hope that you realize that that's really right there. They're giving you a relationship. So you can actually start out with 8.92 minutes over 1 mile because it takes the guy 8.92 minutes to complete 1 mile. That's a relationship. You would start out with 8.92 MIN over mile, or in the abbreviation for mile is MI. And then you would basically take care of this dimensional analysis problem like you would the easy ones. This one just happens to have a top and a bottom that you need to convert. So you just take them separately. I'm going to go ahead and take the minutes to seconds first. I'm going to take care of the top first. So I know that in 1 minute, there's 60 seconds. So I can do that and cross out my minutes, and now I'm in seconds, which is one of the units that they want. But the next thing I need to do is I need to convert miles to inches. This is a good point for me to tell you that you are required to know certain conversion factors. And I have put a list of what is expected for you to know under the syllabus/course materials tab. there's a sheet that you're going to be given every time that you take an exam. So those conversions you don't have to remember. For example, there's a conversion on there that tells you how to get from miles to feet. So you don't have to remember that. But there are certain conversions that you do need to remember, and because they're not on the sheet. So you're going to have that sheet with you when you take an exam. Just make sure that you understand that, because what I would do is I would practice when I do my problems. I would practice with that sheet next to me so that I know what I need to know and what I don't need to know. And then another thing, this is a good point for me to tell you, is that when you do your problems, you have to write out everything. You cannot use Google to give you the one-step conversion between, let's say, miles and inches. That's not going to work in your exam. You have to only use the conversions that you know, that you have been practicing with, because that's what is going to help you with the harder conversions. All right, so now I need to convert miles to feet. I know that there's 5,280 feet in 1 mile. From feet, I can go to inches. And then it's basically all we got to do. I know that in 1 foot, there's 12 inches. So everything cancels out. I'm left with seconds on the top and inches on the bottom. I know that the question is asking for the speed in inches per second, not seconds per inches, but we can take care of that later. But let's go ahead and multiply everything out and divide everything out. So 8.92 times 60 divided by 5,280 times 12. That should give you 8.44696 times 10 to the negative 3 seconds per inches. But again, we're flip-flopped, right? Like the units are flip-flopped. So we have to basically take the inverse of that answer. Take the inverse of that number and you'll get the correct answer, which is 1.1838 times 10 to the second inches per second. Now going back to making sure how many sig figs I need to report, there should only be 3 sig figs, because the only thing that's measured here is that 8.92. So I can go ahead and put 1.18 times 10 to the second inches per second, or I can just take it out into a floating decimal and put 118 inches per second. The next example is going to be really cool for you guys to learn. I am going to teach you how to convert cubed units by hand. And it's really, really simple. And this technique you can use with any power, right? So if I gave you squared units, quadrupled units, it doesn't matter, this will work. And let's convert inches cubed to feet cubed. So you started off basically like a normal problem. But what I'm going to do is I'm going to put 7.6 inches, and I know it's inches cubed, but I'm just going to start it off like if it didn't have the cube there. So 7.6 inches, and I need to get to feet. Well, I know that. That's pretty easy, right? It's 12 inches are in 1 foot. Okay, but there's a problem, right? Because it's supposed to be inches cubed. So since I have to divide it by the same unit, that means that the inches on the bottom has to be cubed. Well, how can I cube the bottom? Well, I can put brackets around the entire fraction and cube the entire thing. Why do we cube the entire thing? In math, whatever you do to the bottom of a fraction, you must do to the top. You put brackets around it and you put a little 3 to cube the entire thing inside that bracket. What you're essentially saying is that the inches cubed from the 7.6 now can cross out with the inches cubed on the bottom, and you've also cubed the feet. So your ending unit is exactly what you want. Okay, this is the important thing though. Whenever you bracket something and you put, you cube it or you square it or whatever, you have to remember that everything in that bracket has been cubed. So not only are you cubing the units, but you're also cubing the number. So the way that I would put this into my calculator is 7.6 times 1 times 1 times 1, which obviously that doesn't matter, it's just 1, but then divided by 12 cubed. So that would be basically 12 times 12 times 12. Okay, don't forget that, because if you do, then your answer is going to be wrong. When you do that, you get 0.004398 feet cubed. But you know that you can only report 2 sig figs because we started with 7.6. So the answer should be 0.004 feet cubed, or if you wanted to put it into scientific notation, 4.4 times 10 to the negative 3 feet cubed. Okay, the next problem I'm actually going to take care of in the next video. It's going to be a really short video that's going to go over that one problem and maybe one more extra problem that I want to do with you guys, because it talks about a very important conversion that takes you from English units to metric units, and it also will show you how to deal with metric unit conversions, basically how to go from meter to centimeter or centimeter to micrometer, so on and so forth. So I'm going to go ahead and leave that for one whole video. It's going to be a really short one. Okay guys, I will see you later. Bye.